first derivation is about the object is in the rarer medium and image is formed in the denser medium, which is a real image, due to a convex spherical refracting surface. Take a convex spherical refracting surface. This is the axis. You have to have an object here which is a point size object. The incident ray goes and falls here, and there is a center of curvature here. Join the point of incidence A and the normal and the center of curvature, which will form as a normal. The ray will enter from rarer to denser, so it's going to bend towards the normal, and you're going to get a final image here. What is angle of incidence? This is my angle of incidence I. This is my angle of refraction R. Correct? Let's mark this object making as alpha, image making as beta, the center of curvature making as gamma. Let's call this as pole. Let's draw a normal such that P is very close to N, so all measurements can be taken from N instead of P. So can you locate the triangle where there is an exterior angle? Can you see that the normal is here? From that you know that this is one triangle in which I is equal to alpha plus gamma. Similarly, you have this triangle. You have this triangle where gamma is equal to R plus beta. Therefore, R is gamma minus beta. You can I therefore is tan alpha plus tan gamma. R therefore is tan gamma minus tan beta. What is tan alpha? From this triangle, can you see from the triangle OAN? From the triangle OAN, right triangle, you can write what is tan alpha, which is AN by ON. What is tan gamma? From this triangle ANC, it is AN by NC. Here also tan gamma is AN by NC minus tan beta. What is tan beta? From this triangle, can you see this from this triangle? Okay, so what is tan beta is AN by NI. So you know this is I, this is R. Here the light ray is entering from rarer to denser. So mu of 2 with respect to 1, which is mu 2 by mu 1, is equal to sin I by sin R. You can write it as I by R considering the angles are small. Let's cross multiply. You get mu 2 into R is equal to mu 1 into I. So substituting mu 2 into what is R? AN by NC minus AN by NI is equal to mu 1 into I, which is AN by ON plus AN by NC. So AN throughout gets cancelled. You can do the substitution for NC. What is NC? NC is radius of curvature, which is on the right side of the pole, so it's positive. What is NI? NI is the image distance, which is V to the right, so it's positive. What is ON? ON is the object distance, which is to the negative, so minus U. Substituting that, you get mu 2 into 1 by R minus 1 by V is equal to mu 1 into 1 by minus U plus 1 by NC, which is nothing but R. Taking it inside, mu 2 by R minus mu 2 by V is equal to minus mu 1 by U plus mu 1 by R. Consolidating R and R, you get 1 by R into mu 2 minus mu 1. So we'll write mu 2 minus mu 1 by R. Therefore, you're taking this to the other side, right? Which is mu 2 by V minus mu 1 by U. And you have to by heart this formula. The refractive index is in the second medium. That's where your image is. So mu 2 by V minus mu 1 by U is equal to mu 2 minus mu 1 by R. And this is your first understanding. The second derivation that they are also saying in Aurora, this is like object in the rarer. Object in rarer. Image in denser after refraction, so it's a real image. You get a real image. Next is virtual image. Object in rarer. Image also in rarer, which means it's going to be virtual image. Okay, so how are we going to do? Just draw this diagram, and this is the center of curvature as usual, and this is the pole, and this is your normal. Okay, now make sure the object is drawn closer. That's when this is your incident ray, and this is your normal, and the line joining the incident ray and the normal is making an angle I. The light ray has to bend towards the normal, slightly only bend so that it will appear to come from a point behind, and this will be your eye. Are you clear? This is the diagram, and if in case they ask you on this diagram, this is a point of incidence, this is AN, and this is alpha, this is beta, and this will be gamma. You try to do the same derivation that we did in the previous one in here, because here also it's entering from rarer to denser. So it is again mu 2 by mu1 is equal to I by r. Same thing. Cross multiply and do. You have to locate the exterior angle, for which you should know where is r. R is here. The refracted ray mixed with the normal. So can you see this triangle here? Where r becomes the exterior angle. R is an exterior angle of beta plus gamma. And similarly, locate this triangle with the normal. Where is the normal here? Always locate this normal here. Can you see thick line here? Can you see this triangle? Where I is an exterior angle. So I is equal to alpha plus gamma. So you write tan alpha, tan gamma, tan beta, tan gamma, substitute everything and do mu2 by mu1 is equal to I by r, cross multiply. You will get the same formula. Same formula, no variation. Try it at home. So then, therefore, whenever the object is in the rarer medium, whether the image is real or virtual, the same formula applies. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Are you clear? So this I am deleting. This is for you to try this extra things. Okay. So let's go to next question. Next question is, the object lies in the denser medium. The object is lying in the denser medium and the image is formed is real. Objects in the denser medium means the diagram is like this. And this is where your object is. And the light ray is entering from denser to rarer. So you know the light ray comes here, you know the center of curvature will obviously be here. This is the point of incidence. Join the center of curvature and the point of incidence, that will be your normal. And this will be your angle of incidence I. Now the light ray is entering from denser into rarer, so it's got to bend away from the normal, correct? When it is bending away from the normal, obviously it's going to come and meet here, and this is where your I is, and this is where your angle of refraction is. So mark this as P, mark this as N, this is alpha, this is beta, and this is gamma. And again you can locate the exterior angles of triangles, which is R is an exterior angle of which triangle? Can you see? R is an exterior angle which has got gamma plus beta. Where again, can you see this is an exterior angle where gamma itself is an exterior angle of alpha plus I. So I is equal to gamma minus alpha. So you will write what is tan gamma, tan alpha, you know, using all right triangles, and right here it's entering from denser to rarer. So you will write mu1 by mu2 is equal to I by r, not mu2 by mu1, and then cross multiply and try to get, use here the object is in the denser medium, so the formula will vary. For this the formula vary. The object is rarer. The formula, with respect to the formula, is always mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. But here it will be different. Here the object is in the denser medium. So in this case the formula will be mu2 by u, not v, minus mu1 by v. Mu2 by u minus mu1 by v is equal to mu2 minus mu1 by r. This will be your final answer in this. You have to try it. You are applying the same phenomenon, you still have to try it. You should know this diagram also. Okay, this is something that you need to know and you have to try it. But what is important is for you to know this one, what I taught you first. This is this forms the basis for everything. If you know this, you can do the rest of the things. This is your thing. Okay, next is the next diagram that I am going to teach you is this. It's about concave spherical refracting surface. It's about concave spherical refracting surface, where it's going to be like this, where object is still in the rarer medium. Object is still in the rarer medium. What does that look? Are you listening? Yes. Concave spherical refracting surface is what I have drawn. Again the light ray will go here and hit here. This is the point of incidence. You know there will be a center of curvature. Join this and see, you will get the normal. So the light ray is entering from rarer to denser, so it's going to bend towards the normal. So when it goes towards the normal, the image is appearing to come from this point here, and I am getting a virtual image. Can you see? I'm getting the same place as where the object is, correct? So this is, the object lies in the rarer medium, and the image is also in the rarer medium. This is one diagram. The other diagram that I would want you to know is, do the same concave spherical refracting surface. Have the object in here, it's coming and falling on this, point of incidence is here, the center of curvature is here, join this and this, you get the normal. Okay, here the incident ray is coming like this. Okay, that is what we did. We just bent it towards a normal and we found that I is here. That is complete. Okay, the next thing that I want to do is, the object is in the denser medium. The object is in the denser medium. Then the light ray will come and fall here. This is the point of incidence. This is the center of curvature. The line joining the center of curvature and the point A is here. So therefore this will form the angle of incidence. The light ray here is entering from denser to rarer. It's going to bend away from the normal, and therefore it's going to appear to come from a point here, which will be your I. This is P, this is N, this is alpha, this is beta, and this is gamma. The three triangles, alpha, beta and gamma are the angles. You have to locate the exterior angle. Can you see that I is an exterior angle of which triangle? This is a normal, right? I is an exterior angle of CAO. I is an exterior angle of triangle CAO. I will be gamma plus alpha. Then locate another exterior angle with R. Where is the refracted angle? Here, which is making an angle R here. Can you see that IAC, triangle IAC, in which R is an exterior angle of gamma plus beta. Correct? Then you can write I to be tan gamma plus tan alpha, R to be tan gamma plus tan beta. What is tan gamma? Tan gamma from this triangle is AN by NC, plus tan alpha from this whole triangle on the right side is AN by NO, right triangle. Then tan gamma again is AN by NC, plus tan beta is AN by NI. Take the respective right triangles and write what is I and R. Here the object is in the denser medium. So it's entering from denser to rarer. So you should write mu 1 by mu 2. It's 1 by mu of 2 with respect to 1. So it's mu 2 mele mu 1 is equal to I by R. Cross multiplying mu 1 into R is equal to mu 2 into I. So mu 1 into what is R? AN by NC plus AN by NI is equal to mu 2 into what is I? AN by NC plus AN by NO. AN throughout will get cancelled. Let's write what is NC. What is NC? Is minus R, because it is to the left. Whereas the object distance and the image distance are both positive, it is to the right. So let's substitute mu 1 by minus R plus 1 by V, because Ni is V, mu 2 into 1 by minus R plus ON is object distance U. Multiplying it inside, you get minus mu 1 by R plus mu 1 by V is equal to minus mu 2 by R plus mu 2 by U. Correct? Now I'm going to consolidate R and R. I'm going to bring the R to the left side. So 1 by R, again 1 by R into mu 2 minus mu 1. So I'll write mu 2 minus mu 1 by R as usual. Mu 2 minus mu 1 by R is equal to, I'm going to take this to the other side. So I'll get mu 2 by U minus mu 1 by V. Didn't I tell you? Whenever the object is in the denser medium, it's always mu 2 by U minus mu 1 by V is equal to mu 2 minus mu 1 by R. Are you clear? So this formula you need to know. Next is Lensmaker's formula. Lensmaker's, what he is doing, he is taking this spherical refracting surface and he is taking this spherical refracting surface that we did now. This one combined with this one, and he is making a lens. You understand? So he is combining these two, which means he is taking the final formula of this and final formula of that. Are you listening? Where according to him, he is saying in the first or you got an image that is going to become an object for the second, because he is going to combine and make a proper lens. The image in the first is going to act as an object in the second. You understand? So I'm going to do a combined diagram. So the lens maker now is making this lens with this surface and that surface cut, correct? Where the original object was here, it went and stuck here, and then it actually formed here. Actually we got a real image, but I am doing a dotted because that is going to serve as an object for the second surface. This O is an object for the first surface. This I am not going to call it as I am going to call it as I dash, which is going to serve as an object for the second surface. And so then my final image will be obtained here. You understand? So this is the combined diagram. This is O, this is appearing to go here and comes back here because also an object, and the final image is here. This is the diagram. Okay. So this is what is Lensmaker's diagram, and we are going to derive Lensmaker's now. So we are going to derive Lensmakers. Can we continue? What was the final formula in the first one? Mu2 by u minus mu1 by v is equal to mu2 minus mu1 by r for the purple surface. You did it for the purple surface. You got it like this, remember? But that v has to be written as v dash because that's not going to be the final image. It's going to serve as an object for the green surface. Are you clear? It's mu2 minus mu1 by r1 because the radius of curvature of 2 cannot be the same. For the next one, what was the final formula? Mu2 by the first one's final formula is mu2 by v. Correct panna matingla. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. Enna gavanikringane therla. I told you the first one's final formula is mu2 by v minus mu1 by u. Gavanikamiya ukkan summa bomma mari ukkandanda eppadi soltharudhu? But in this v is not v becomes v dash and r becomes r1. This is the purple color's final formula. Green colors is mu2 by u, but u is nothing but v dash minus mu1 by v is equal to mu2 minus mu1 by r2. So you convert those two formulas like this. Are you clear how I am converting? So you have to convert the first equation. Adode object, adode image will be the second one's object. And when write the second equation, the object here will have to be written as v dash. Mu2 by u will become mu2 by v dash. Now you can solve this too. How to solve your? Yeah, the formula is what? Mu2 by u minus mu1 by v. No, second one. Final image dana. Mu2 by u minus mu1 by v. V is only the final image. So you write these two equations. Now what you do is you're going to solve these two equations. Can you see this and this are same? So can we just subtract it? So this will become addition and this will become subtraction and this will get cancelled. So this has to be written first, which is mu1 by v because it's become positive, minus mu1 by u is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. Now you can take mu1 completely out. 1 by v minus 1 by u is equal to mu2 minus mu1 into 1 by r1 minus 1 by r2. You can strike this and bring it down. Then you can, this itself is 1 by f, which is Lenz formula. Lenz formula is 1 by f is equal to 1 by v minus 1 by u is equal to, this can be split as mu2 by mu1 minus 1 into 1 by r1 minus 1 by r2. Therefore 1 by f is equal to mu of 2 with respect to 1 into 1 by r1 minus 1 by r2. This is what is called Lensmaker's formula. It's always denser with regard to rarer. Minus 1 into 1 by r1 minus 1 by r2. Are you clear? You must be very, very clear with all these derivations so that we can continue with the numericals.